Well, hello friends. Welcome back to browser hacking. Today we are going to work on some browser architecture stuff. So we have this issue right now that the JavaScript engine that we instantiate when running in the browser, for example, here we open a page that has a little bit of JavaScript on it, and what we do is we create a JavaScript virtual machine or a JS interpreter, and then we execute the script. But the interpreter that we create, it is owned by the document. So this web page here owns an interpreter, so when we navigate away from it, that interpreter is now gone. And this works more or less okay for simple pages, but as soon as you throw in frames or things like window.open, then you need to be able to have multiple global objects that exist within one JavaScript virtual machine, because like different frames need to be able to access each other if it's allowed, for example. So this is something that our current architecture does not allow for. So for the longest time, I've been meaning to do something about this, and it's just the kind of thing that I keep pushing in front of me instead of dealing with. So today we're just gonna like hunker down and deal with it. So basically, let me show you where the interpreter sits. So this is the DOM document object in libweb, which has an M interpreter. This is the instantiated JavaScript interpreter inside of a given document. So whenever we encounter a script element, such as this one right here, inside of a HTML document, then we will instantiate this interpreter if not already present, and then use that to execute JavaScript. Now in the new world, we're not going to be able to hang the interpreter off of any specific document object. Instead, it needs to be sort of I guess like more of a floating thing that exists somewhere else. And a document instead needs to create a DOM window object. And whenever you want to execute scripts in the context of a document, then you take your DOM window object and pass that to sort of our floating global interpreter and say, hey, here is a piece of JavaScript code that I want to run, and this is my global /window object, right? So that's sort of where we want to get to. Now, I'm not exactly sure how we're going to approach this, so I guess we'll just start by sort of restructuring the code the way that in a way that would facilitate this kind of architecture, and then we'll see if we can coerce the code into complying to the new architecture. So first thing is we need somewhere to instantiate a single global interpreter inside of the inside of this thing. That's what I was thinking, but let's see. The interpreter has a global object. So that's currently one of the flaws here, that our interpreter object, the way that you construct an interpreter is that you pass it the type of global object that you want to use, and then you get the interpreter constructed together with a global object. So constructing an interpreter implicitly constructs a kind of global object, and then you're stuck with that global object. You can't switch the global object that runs in an interpreter. So actually, maybe that's our first architectural issue that we need to address. So this is the JS interpreter class, and if you look here at the bottom, we have a global object pointer. So really what we would like to do is instead of having a global object permanently here, you would provide a global object when you tell the interpreter to run some code, and it will run with that global object until that code exits for whatever reason. I think that might be a decent first step. Another approach could be to separate out, so the interpreter would be sort of a thing that you almost create like on the stack where you want to run some code, and we would have more of a like a virtual machine object that is persistent in memory, and then so you would have a JavaScript VM object that sticks around, and then when you want to run some code, you construct an interpreter, and then let's see, how would that look like? So it will be something like say that you want to run some code, so you have your VM my global VM, something like that, and then you want to run some code now, so you have string my JavaScript code, and then you would create an interpreter, maybe like passing the VM, and maybe also passing in my window object. So that's like the global object. We'll say DOM window object. And then interpreter run my JavaScript code. That's kind of cool, because then the interpreter would have the call stack and exception state, things like that. And once execution is finished, you can just throw all of that out. I kind of like that. That's a pretty big architectural change though, but I guess, so what was my other approach? My other approach was essentially to just have a persistent interpreter, global interpreter thing, and then when you want to run my JavaScript code, then you would do something like interpreter run my JavaScript code in the DOM window object, and then the interpreter will always stick around, but while it would be running in the context of different global objects or window objects, depending on what you pass to run. So in some ways, this approach feels like a smaller step, but this approach feels a lot better architecturally, because this approach allows the interpreter to be tied to a given global object, because the interpreter is transient, whereas here the interpreter sticks around, so it would have to like constantly retarget itself to new global objects. And maybe this is easier to reason about. So let's go with this approach. I think that'll work. Man, this will be a bit of a refactor. Okay, so let's just tolerate it and see if we can do something incrementally here. So we'll need a VM object or a virtual machine. Let's call it VM. Okay. Runtime. Runtime VM. All right. Jsvm. Hello? Hello. So what is a VM? A VM VM is this thing that sticks around always. So this is where we will hang the JavaScript heap, for example. The heap has to be shared between all interpreters so that we can persist all of these global objects. So it has to have a heap. In fact, it will be responsible for creating the heap, so we'll just make the heap a value member. Heap. Okay, there's our heap. And we'll provide a friendly accessors for the heap, let's say. And I guess maybe we should make this thing reference counted so that if you want to, let's make it easier to shared ownership here. Wait. Let's see. Do that, make that private, and then we will create a static. Thing. That seems fine. Okay. Okay, so we'll start with this. And in VM CPP, hello, we will simply include okay, so okay, heap needs to has some constructor arguments, I guess. So let's take a look at that. Oh, right, so the heap has a back pointer to the interpreter. So currently, today, the architecture is that the interpreter object holds the heap by value. So this thing is going to move, so the interpreter will instead have a non-null ref putter to a virtual machine. And when you create an interpreter, you will have to provide a virtual machine. Okay, so this will be a pretty good first step, I guess, for the refactor here. Runtime VM. So mvm heap. I don't know how far we'll be able to take this in one video. Like this has a little bit of a large time sink feeling to it, but we'll see what we can do here. So I guess we don't need the const variant there. So when we construct an interpreter, we must now provide a VM ampersand, let's say. So then everybody who creates these guys, this will require messing with a bunch of code because we instantiate interpreters here and there, and they need to make a VM first. But we'll take care of that. So heap, go away. VM is the new coolness. Okay. And do we have anything touching mheap? No, we don't. That's really good, actually. So let's see. So in the JavaScript REPL program, for example, like what breaks now because we changed this. So this is the way we instantiate an interpreter in the REPL. So it's a JS interpreter create, and then the type of global object that we're using, so REPL object in this case. And here we need to provide the VM. So I think what we'll do here is just something like Jsvm create. And something like that. It's almost like we could, I mean, I'm kind of getting ahead of myself. I was just thinking that we could give the VM a function that produces an interpreter, because then you don't have to call JS interpreter create. You could ask the VM to make you an interpreter, but let's not get ahead of ourselves. So here we just use start VM again, and we are good. So obviously this is going to break a whole bunch of things. So let's just go through these one by one. Starting with JSVM CPP actually, because here we have to say mheap. So we're going to give the heap a back pointer to ourselves instead. Heap h. So instead of the interpreter pointer, oh, I bet that pointer is used in a billion places, so that's something we have to deal with, but we'll get to that. So we'll make a back pointer to the VM, like so, and in libjs forward, where we have all our forward declarations, let's just forward declare the VM. And here, do we use this in a lot of places? Heap interpreter. There are 2 calls. Not terribly many. It's when you ask for the interpreter from a cell. Now that is used in a lot of places, like a lot. Okay, so currently we need to be able to go from a heap cell to the interpreter. So I think, at least as a stopgap here, we're going to need some way for the VM to know the sort of the current interpreter. So we'll move this out of line, and maybe we'll add something like this. Return MVM and heap VM, MVM, VM, 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 VM. Okay. And the way you get to the interpreter is that we just ask the VM for the current interpreter. Something like that. Yeah, I think, and then we'll just figure something out there. And then here, this is when we start garbage collection, we do VM interpreter, or maybe something like that even. I'm not sure. Yeah, this is going to take some untangling, but we'll push forward. So JSVM. Maybe we'll have a, what if we have a stack of interpreters so that if you, because I'm thinking like, yeah, we need to have a stack of interpreters, I think, because you could have a piece of JavaScript that runs that causes a synchronous event to be delivered in the DOM, for example. And then in the callback for that thing, you do something that necessitates the switch to a separate interpreter. And then you don't want to lose track of the first interpreter that brought you to that callback. So brought you to that event delivery thing. So we'll have to like push a new interpreter on the interpreter stack. I think that's how this is going to have to work. So we'll make interpreter stack. Interpreters. I hope I'm thinking right about this. We'll see. We'll see. I mean, we'll find out pretty soon if this is all wrong. So interpreter, and then here we'll assert that the interpreters is not empty, and then we will return interpreters last starred, because you should really only be calling this from code that that needs the current interpreter for some reason, right? So it will be a bug to call it while JS is not being interpreted. And maybe we need an optional variant of this. Interpreter if exists. Interpreter if active, let's say. This this is a variant of this. If interpreters is empty, return null putter. Otherwise, return interpreters last, because we needed that when we do the when we start to gather roots to do a garbage collection, because we can't be sure here. We might do we might start a garbage collection just because a timer has run out, and like if we have this periodic garbage collection mechanism, right? And then you might want to do a GC when there's no interpreter active. So in those cases, you might not have one. So here, we'll do something like this. Interpreter if exists. And if so, we will gather the roots from the existing interpreter, if one exists. Okay. And then, how do we get interpreters onto that stack, though? I guess we'll have some API for that. So, like, push interpreter, maybe? Pop interpreter. And what will these do? Well, I mean, they're kind of simple, right? We just need to get the interpreter on and off the stack. So in this case, we will simply append it to the stack. And in this case, we will I guess we will assert that the stack is non-empty, and we will assert that the last item in the vector, so top of the stack, is the same interpreter that we are popping, so that we are not confused here. Otherwise, we might be popping the wrong thing off the stack, which would be unfortunate. And then we have take last. I guess we can do this. Popped. Take last. Assert. We want to assert that they are the same, actually. There we go. Okay, that looks pretty good. Probably we don't need anybody but interpreter to call this. So we could probably take a batch here. Yeah, I feel pretty good about that one. Okay. So we we are in test.js. I guess let's go and clean this up so that it builds. Oops, this is the JavaScript test runner program. I'm just looking over at the scroll bar here where the red is. So we need to provide a VM. Say like JVM. So the test runner, I guess this will be a good test vehicle for keeping a persistent VM. So we'll just make it here. Static JS non-null ref per JSVM. Actually, it can't be like that. We'll do it like this. Or, well, we want something that we can destroy when we exit, so let's do it this way. Okay, so star VM right here. Okay, and where is main? Main is here. So we'll construct JSVM create, and before we exit, we will null putter the aforementioned VM. Okay, very crashalicious. JSVM create missing. Of course, we never implemented that. So that's a non-null ref putter to VM. VM create. New VM. Okay, DOM document. Here. Okay, so this is where the DOM document constructs its interpreter, if not already present. So we need to provide it with a global VM here. So I guess we'll do this thing that I was saying earlier, that we'll just, I guess for now we can just make a helper that returns one, like this. Say that it's static. Nobody else needs to know about this little secret of ours. A global VM, and thinking, what is the reason that, so there will be more than one VM eventually in this process if you want to use web workers. That's when we'll need more VMs, but as long as you're not using workers, everything will go in this global VM. So this is like the main thread VM, I guess. So maybe we should call it main thread VM. Yes, and then because a worker is a similar context, sort of on the same conceptual level as a document, because they're both scripting contexts, sort of. So we'll need something once we get to workers, but we don't have any workers, so that's okay. We'll get there someday, and we'll worry about that then. But right now, let's just make a main thread VM, and if we had something like is main thread, then I would assert that here, but we don't have such a thing. But we also don't have multiple threads in the web engine, so let's not get ahead of ourselves. Static ref putter to JS VM. VM. If no VM, then VM is JS VM create. Return star VM. Beautiful. So now we are creating a very different execution environment for JavaScript in the browser, especially because now the JavaScript heap will persist. So when you go from page to page, we're not like clearing out the heap. We're going to be reusing the heap. But that will also be significantly faster than like constructing a new heap and throwing away that heap whenever you switch from page to page. And it's just absolutely necessary to support a bunch of basic features that we need. So it's not like we have a choice. But it should remove some performance bottlenecks that we currently have, where we spend a lot of time allocating and deallocating heap blocks when you navigate. Anyway, so this is the JS interpreter in the Spreadsheet application. So here it has a persistent interpreter. I mean, everybody does at the moment. So I think for him, we'll do exactly what we did in the DOM document case. We'll just like make one of these puppers, and so I guess the global VM, and then we'll deal with that at some other time. I don't exactly know what the architecture should be here. We just need to, the spreadsheet application is not a primary concern right now, the architecture of that, because it's, you know, it's a new application and it has way fewer architectural needs, I think, than the browser. Okay, so this will likely break, yes, because nothing, we're not putting anything into the interpreter stack. Right, I just added APIs for it, but I didn't actually use them. So, whenever we want to run code on the JS interpreter, what do we do? Interpreter run, right? That's what we do here. Interpreter run. We call it run with a global object and a program. At least this is what the spreadsheet application does. So I'm thinking that the run function can simply push itself onto the VM. So like VM push interpreter this, and let's make an RAII helper for this, because otherwise I'm gonna screw this up somewhere and forget to pop. Because you can see already we have like 2 return paths out of this function. So interpreter scope, let's say something like this. Maybe the exception state should move to the VM. Nah, no, let's keep it on the interpreter. Let's see, class. Interpreter, scope. Interpreter. And wait a minute. Wait, how do we make this work? We could also do something like scope is VM enter, something like this. And this object that it gives you back, that kind of works. Although that's not as nearly as expressive as this. Okay, let's do it this way. kind of like the way that reads, so that's why we're doing it that way. Private interpreter and interpreter. Okay. Interpreter. Okay, so interpreter VM, interpreter VM, push. Where is the interpreter here? Oh, now we are not in the interpreter. Okay, so that badge actually ended up not being necessary. And in fact, we can maybe even get away with these not even being public. Wouldn't that be kind of cool? Well, okay, let's not get fancy. Let's stay focused. So push interpreter, interpreter. And here interpreter, VM, pop, interpreter, and interpreter. Right. So the VM will now transition in and out of interpreters, I think. Still not good. So what am I doing? Oh, I'm just trying to construct the interpreter and it already falls apart. Okay, so we're not trying to run. We're calling VM interpreter. We don't have an interpreter for the VM. Why are we doing that? So we're in the construction of window object, constructing global object, constructing object, object constructor calls interpreter. Let's take a look at that. Object. And here we are calling interpreter. So it might, if we just want to get to the heap from a cell, we should just call heap. Although heap will, yeah, because this, if to get to the heap from a cell, because all the cells are somewhere inside of a 16K aligned block, then we can actually derive the base of the block from the cell pointer by just masking its bits and then find a pointer to the heap from there. Because each heap block is 16 kilobytes, it's aligned on 16 kilobyte boundaries, so it's just a pointer masking strategy to get to the heap block, and then you can find the heap from there. So I think the solution here is just not to go through the interpreter, which we were doing for some reason. In fact, if we look at interpreter, we'll see that cell interpreter goes to heap and then back to interpreter. So this is just completely redundant indirection. All right, so then we are in define native function. And what does that do? I guess let's get a line number so that we know what we're doing. So adder to line, executable, as Andy would say, and 753, so straight here. So native function create with an interpreter. Now, why does native function create require the interpreter? It does not. It doesn't even use it. So, seems like we can get rid of that. we're probably going to find a bunch of things like this, like places where we're calling interpreter unnecessarily, but that's like good solid cleanup regardless. Native function, yeah, but then like we're calling interpreter exception here. This is gonna break there, right? Define native function. Yeah, because so maybe we do need to move the exception state to the VM. But maybe that's okay. Maybe it's okay. Let's see. I mean, we can just try it. So yeah, I mean, this is not going to work otherwise, because here we are constructing the interpreter. Or wait, what is this even doing? Let's go take a look at it. So we're calling interpreter, which calls JSInterpreter create, JSInterpreter create, interpreter. So we are here, and then we've constructed the interpreter, and we are currently here calling initialize on the global object. So interpreter window object initialize. That's our global object, the web bindings window object. So we have an interpreter. It's just that that interpreter is not it's not on the VM's interpreter stack at the moment. So a way to work around this, to avoid having to move the exception state from interpreter to VM, would be to just push ourselves on the VM's interpreter stack here while we're constructing. That seems like a good compromise. Otherwise, this patch is going to grow to like 25,000 lines suddenly. So let's see. So VM interpreter scope A interpreter. But this architecture is kind of interesting because ultimately we don't want to construct the global object here. We want the global object to be this thing that persists outside of the interpreter. So this will eventually go away. So we'll see. Okay, so where are we now? Now we are in event dispatch all of a sudden. So we are in document parser run, and we have a DOM node where we're dispatching an event dispatcher dispatch, and from there we want to call the interpreter. So let's go look at event dispatcher, and the interpreter is fetched by calling function.interpreter. Well, now we can't really do that. We need to get the interpreter from elsewhere, because it used to be that any cell could have, I mean, every cell still has the interpreter getter, but if you're not currently executing in an interpreter, then there is no interpreter. I mean, that's kind of the new architecture that we're going for, right? So here we want to perform a call, actually, which also is kind of a questionable API for interpreter, but that is an entirely separate concern. So call function this value, and what the heck is the third argument here? wait, call marked value list. Is that what we're passing? I forget how this works. Oh, it's like this. I see. Okay. Right. So it becomes a marked value list. That's fair. So, what do we want to do here? Well, for now, we need to get the DOM documents interpreter. How do we get to the DOM document? Well, we have an event target object, and we need to get from him to the DOM document. So let's see. Event targets currently, they don't have, it's not necessarily a DOM node. Like event target can also be something like an XML HTTP request, which, as you can see here, XML HTTP request is a DOM event target, but it is not a DOM node. So it doesn't have a way to get to the document. But we should have a way to get to a script context, script execution context from a given XML HTTP request. That should probably be a thing that event target has. So event target needs to have an accessor, script context, execution context. Let's say yeah, something like that. And then what is a script execution context? Well, we'll have to define that. I think we'll put that in web bindings, maybe? Or DOM? Is this bindings or DOM? Let's say that it's DOM. Okay. So script execution context. Yeah, this is going to be a very iterative process. We're definitely not going to be able to finish everything in one video, but it is good that we've started. So script exec, lice, namespace web doom, and so this will be the base or a base class that's shared among DOM document and a worker. Yeah, so once we get web workers, they will also inherit script execution context. And script execution context, I suppose, will be sort of your abstracted link between arbitrary JS objects in the DOM space and the JavaScript virtual machine. Some kind of a handle, I guess. Anyway, right now we just care about finding something. So maybe we'll, for now we can just cheese this. So, or wait, what is it that I want to do? I want to be able to give you the interpreter. I want to get the interpreter. So for now, this will be kind of ugly, but we'll do it this way. and put a fix me. So virtual JS interpreter. So this shouldn't really work this way. Fix me. This should not work this way long term. The interpreters should be on the stack. Just so that we remember to clean that up. Okay, so then DOM doc needs to inherit this thing, script DOM. Okay. And then we can say interpreter, we can just make this thing virtual override. And, oh, right, I forgot to actually inherit. Script execution context. Very spicy. Okay, so now that we are a script execution context, we can also go ahead and say that something like an XML HTTP request, which inherits event target. We'll say that event target requires that you pass a script execution context. I think that makes sense. And when so we'll have a reference to this. How's this going to work? And then we kind of want to learn if the execution context disappears, then we would kind of like to know about it. But so it should probably be a weakable, so that you can make a weak putter to it. And then that's how we'll store that here in event target. So weak putter to script execution context, so that we don't try to use it if it's gone. Okay. And script execution context. Make a weak putter. Okay. And then when we construct these things, this node CPP. So this guy needs to initialize the event target base class here. So we'll just do this. Because we can just pass in our document, because the document is a script execution context. Event target. Wait, why is that ambiguous? You jerk. Candidate constructor has been explicitly deleted. Has it now? Why? Candidate constructor 63, 39. Wait a minute. Node is an event target. Yeah. Okay, wait. I need help. New XML HTTP request. New XML HTTP. So when we're constructing these guys, we need to pass in some script execution context, which I guess will be our document. Wait, what's wrong with this? Oh, it's abstract class marked as final. It's an event target that doesn't know how to get to its execution context. Maybe this thing doesn't need to be virtual. Or could do it like that. And then here in the constructor for this thing, we just call event target window document. And again, the ambiguous call. Make weak better. Oh shit, we're inheriting from weakable twice. That's a little nasty. Let's see, event target with this. Does that work? It's kind of weird. I'm a little bit skeptical about the class layout here, but we still have that double inheritance. Yeah. So script execution context can't inherit from weakable like that, because JSvm nodes are already weakable. That's a little bit frustrating. But I think maybe we'll just tolerate it and not worry about that, and we will use a raw pointer here for now, and then eventually we'll replace this with some mechanism. Fix me, this should not be a raw pointer. That double inheritance is a bit of a bitch there. Okay, so oopsie doopsie, then we will just tolerate that. Script execution context, destructor missing. Makes sense, we didn't implement any of it. Maybe this should be a bindings concept. I don't know why I put it in DOM. Probably move it later. But whatever, it's not the most important thing right now. Okay, so we're still in the same space. We just need to solve this differently now. So in event dispatcher, right, so this is where we were. So instead of asking the function for the interpreter, what we want to do is ask the target for the script execution context interpreter. Okay. Web script exec context. Okay, where are we now? Now we are in interpreter call internal. Okay, so now we're performing the call here. Call internal Okay, so these guys call internal, and call internal is apparently a public API of the interpreter, much like run. So it's going to have to push the interpreter on the scope as well. I think that's okay. It is weird, like the JS interpreter is kind of an implementation detail of the engine and also a public API, but it's like has all these different things on it. It's a very overloaded API. But in this new world where interpreters are supposed to be temporary objects like transient on the stack, it will be nice because we'll be able to scale back what the interpreter does and what his responsibilities are and so on. Okay, so we loaded. We ran some script to put the user agent here. Let's open up a page with some JS on it. Yeah, go back. So this is pretty cool. So now everything should be in the same virtual machine. What happens when we exit? Do we crash? Nope, just exit. That's good. Let's open something that runs periodically, like the set interval test. Okay, there's a crash. So DOM window timer did fire. DOM window timer did fire. Here we are using, well, we're asking the wrapper for an interpreter. And I mean, so in the future, the way that this code should look is different, right? Like it should be something like JS interpreter with wrapper global object, something like that. And then interpreter call, timer callback, whatever. Like this is what it should ultimately look like, but we're not there now. So we have to deal with the fact that it's trying to get the interpreter from the wrapper object. The wrapper object is the DOM window wrapper object, which means that it's the global object, actually. The window object. So here, we just want to go and get the document, actually. Like that. So we can probably do this in a couple more places. Here we're getting function interpreter like that. We can just get document interpreter. Oh, this is a callback. Oh, hold on. Okay, that one is a little tricky. We'll have to get back to that one. Something like this is for request animation frame, which will you'll get a callback in a completely different context where you don't have the only thing you have at that point in the callback is like the address of the JavaScript function that you're supposed to invoke for the ref callback. So there we don't have a good way to get to the interpreter the way that we currently set things up, but maybe it's okay to break that case for now and then just kind of return to it once we're closer to the architecture that we do want. But at least something like this will work now. And let's try to open a new tab. So we're running the script here, that works. And what if we have, where is that set interval? So this thing is counting up. This guy's counting up over here, 18, 5. And if we go back, it shouldn't say 18 still, right? It should be like 20 something. 24. So this is pretty cool. Now we have two separate JS interpreters running in a shared VM. So they have a shared JavaScript heap. And the interpreter still hangs from the document object, but two interpreters, one heap, basically. So this is definitely progress. So I think we're gonna try to slow down here and do some commits and stuff because I've already changed up so many things. Let's just do a smoke test to load Google. That did not work well. We crashed. When, oh, it looks like we're crashing in a garbage collection maybe, or this is one of those crashes that you normally get when you screw up garbage collection, which is fair. Does test.js run? Definitely not. Okay, so we should probably make test.js run. Let's see. Test.js. Sig Abert. What does test.js actually do? Test.js creates a VM, test runner, run file test, and here we create an interpreter. And then interpreter run. And then what? That's so weird that we can't see what happened before here. Alright, so VM, I don't know why the call stack looks like this. That's weird. So let's see if we can just hack our way around this to see what's going on. Or maybe we can even use the debugger actually, because we have a debugger, I just never use it. Program exited. Well, it would be nice if it would drop you into the debugger when you get a SIG abort. Okay, so if it's empty, then we will crash instead of asserting. Okay, asm volatile, undefined opcode. Just hit me with something that crashes. Okay, that's a crash, and we are in run file test. Okay, so wait, this is not the right place. This is the right place. This is test.js. Okay, so get variable. So we're calling get variable, which get variable calls object get, which expects interpreter to work, I suppose. Yeah, so again, like this needs to, like anything that uses this thing as a public API, it needs to push itself on the interpreter stack. Scope is kind of an unfortunate term actually, because scope means something else in JavaScript as well. What? Nah. Okay, still crashy. Stringify impl. So like, why do all these things need the interpreter, by the way? That's kind of weird. I mean, they call object get. And object get will, okay, so it's about the exception. So if we move the exception to the VM, this will probably become a lot nicer. So maybe what we should do here is, instead of doing this for everything, we can also like work around the architectural issue by just pushing this interpreter on the VM stack. Jsvm interpreter scope, something like that. Hack, fix me, this is a hack until, while we are refactoring interpreter VM stuff. yeah, so we'll just like push the test runners interpreter on the VM interpreter stack for its lifetime. All right. So now we're dying somewhere new. Cool. Is this thing? Oh, it's handling Sigabort. That's why things are so weird. Handle Sigabort. Handle Sigabort. So this is what's ruining the backtrace stuff. So let's just not do that. Handle Sigabort. I just want to see what goes wrong. It's kind of irritating that you can't get a proper backtrace. It's probably something we should look into, like better backtraces when you're getting a signal. Wait, that's not what I wanted to do. Test.js. Okay, so where are we now? Interpreter create. Initializing the object. Add constructor, blah, 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 in strict mode. But interpreter create should have pushed the interpreter on the stack. Didn't we do it that way? So he goes on the stack here. So global object initialize, add constructor, define property, put on property, in strict mode. Where the hell are we crashing? That's such a weird place. Let's see. Userland test.js. Interpreter 158. Scope stack. Oh, scope stack last. Okay, so it's checking. Interesting. Put own property. Wait, but what if we're not in the scope? This is weird. Why is this code structured this way? In strict mode. Put own property. We will casually call in strict mode. Sure, that makes sense. But why does in strict mode check the scope stack? What if you haven't entered a scope? Like when you're initializing a new global object, you might not be in a scope. Why did this work before? I'm confused now. Scope stack. Do we like always enter a scope? Scope stack append. We append when we enter scope, right? And when do we enter scope? When we execute a statement, for statement, a variable, no, it's a for statement again. So when we execute something, then we enter a scope. I am so confused by this right now. Like, why does this actually... Why did this work before? In strict mode. So I guess, I mean, I don't know why this didn't break before. There's probably some reason. I'm not going to track it down now. I'm just going to say that if the scope stack, if it's empty, then we'll just say that we are in strict mode, I guess. Because then we'll just consider ourselves in strict mode while we are doing like object initialization. Maybe this will bite us in the ass somehow. I don't know. That's so weird though. probably some explanation for it. I just don't. Okay, now we are crashing. When creating a type error. Okay, so we have lots of crashes to fix, it seems like. Type error creates an error, and then error wants to get the prototype. Prototype is gone. So we're running a few tests. If we collect more often, then we die immediately. Well, that's good. Then we can use that as a smoke test tg test JS. Okay, so why are we crashing so soon? Interpreter create. So like we're crashing very early because of garbage collection. Garbage collection ruins everything. Okay. Why? I mean, we should definitely like turn off the garbage collector while we are constructing a global object anyway. It's just kind of weird. So let's see. Test runner global object initialize global object. Okay, so let's go to global object initialize, and then here let's just say that like defer GC heap. Because right now we start constructing prototypes and stuff, and then we just die in the middle somewhere in between, because these things are not like protected properly while they're being set up. Okay. And undefer GC. Great. Fun stuff. Garbage collection problems. So wait, should we let this thing finish up completely, maybe? Maybe this needs to be here instead. Initialize. So can we make a defer GC thing here? Maybe like JS heap defer GC. Let's just make one right here. Defer GC on the end heap. So we don't GC across the entire construction of an interpreter and accompanying global object. I don't know. Is there there's dragons in there? Garbage collection during global object construction seems like it's like a minefield, right? Because you're setting up all these things that point to each other, and you don't want to be interrupted in the middle by the garbage collector saying like, "Aha, this thing does not point to that other thing that it normally should." Of course, we are still failing, but we can at least see what is failing. Scope node execute. Okay. So we have a null pointer. Interpreter run scope node execute. Wait a moment. So I'm guessing what happens here is that we moved a bunch of stuff So normally when the heap starts a garbage collection, it will look for all of the roots, all the root objects or root pointers or whatever. These are sort of entry points into the object graph. And previously, since we always had a pointer to the interpreter, we would unconditionally gather the roots from the interpreter, and the interpreter will have all of the things like the global object and the exception. So I'm guessing that currently the global object will get garbage collected if you are not currently running something while you get a GC. So if you get a garbage collection while you're not running, while you don't have a current interpreter, then the global object will go poof. That's not very good. So we actually kind of need the interpreter to have a stronger reference to the global object, but that makes sense. So we'll make a handle to it instead of a raw pointer. I think that'll be a first step. Global object. Make a handle to that. Can we get this to work? Let's see. Then what static cast this thing to a global object? Or wait, what kind of thing is this even? It's a handle object. Okay, so we'll just static cast it to object. $355. So the handle is essentially, the handle is a strong pointer to a to an object on the GC heap. And if you have a handle to something, then you don't need to manually mark it during GC mark. So we don't need to do that anymore. And it will also guarantee that the object stays alive even if we are not currently running JS. So I'm guessing that was the problem here, that we were, the global object was getting collected. Because we only mark the global object if we have a currently active interpreter. Still very crashy, sure. Let's see, global object. Let's see if we're destroying these things. Are we? Debug global object. I'm just kind of curious now. Okay, so we did destroy a global object. That is normal though. Like, what happens if we just run the browser? We go here, then we go away from it. And then we collect garbage, which kills a bunch of these, but everything's still good. So, yeah. Seems fine here. Oh, no, there we had a crash. Okay. So it seems like we have some issues here. Okay, so we're still having these issues that things probably get garbage collected way too soon. And we don't quite know why, but at least we are able to reproduce it easily by just running a single test in the test.js app. So this crashes immediately when we undefer garbage collection. Actually, one test passes, and then things go wrong. So what is it that hangs off of interpreter? Stuff that will now go away, or let's see. Just thinking, what have we changed structurally about the test.js application? So previously we would have, we would instantiate a single interpreter for every single test, which means a single interpreter, a single heap. And now we keep the heap, but throw away the interpreter. But nothing hangs off of the heap itself. How do we approach this problem? I guess we need to figure out what's being deleted and what's surviving. So let's just turn on Heap Debug. We can learn a bit more. Okay, that's very verbose. So, is this all just a single garbage collection? I guess this is like throwing out everything associated with the test that we just ran. Quite a few objects here. Here's a global object. Okay, so this is like a single garbage collection, it looks like. But let's run that again with GC after every allocation. Test.js. So it's working fine, it seems like, because now we're doing like multiple garbage collections, and every time we try to allocate something. This may take a while. But what is it that we expect to survive after a GC? It's really nothing. I mean, we don't expect anything to survive if the interpreter is gone. So like if there's just a heap left, then it should be empty. Okay, so this is taking too long. Okay, this is kind of, this type of issue is kind of annoying to track down. Let's see if we can run this on the host machine instead. Now we have some additional tools. Test.js, yes. Okay, come on, Valgrind. Now is your time to shine. Totally bogus address here. Invalid right. Okay, now we are talking. And let's see where the first invalid access is. So, oh wait, what's going on here? Ensure property table creates a defer GC. Wait a minute. Ensure property table makes a defer GC. There's something really goofy going on here. So we're doing a visit children. So we are in marking, and then during marking we call ensure property table. Now that's not right, because this will allocate while we're marking, or it may allocate, and it ends up doing a defer and undefer, and then when we undefer this RAII object, it says, oh, well, there are no more deferrals, so we have to go into GC. And then we GC while we're already in GC. So this here, why is this being called during marking? That's what I want to know. Ensure property table, visit children. Okay, so we should not ensure property table during marking. Why do we do that? It's presumably so we can iterate the property table of a shape and look at all of its keys. So we want to mark all of the keys in a property table. What is a key in the property table? It is a string or symbol. Okay, so we are, I guess this is marking symbols. Yeah, so visit children. If it's a symbol, then we'll mark it, but we don't need to do that. It's only necessary if we have a property table. So if we have a property table, then we will mark it. Don't need to reify or like ensure that one comes into existence. Just to mark it. So can we get a val grind run again? Oh wow, now it runs a lot more. Significantly more. So would this even complete maybe? It even completes. Holy moly. Okay, so let's just see if it runs here. JS. Ugh, it's too loud. But I think that was probably the issue. So the reason that I wanted to run it on the host was to get Valgrind, and that's because we can't run test.js in the user space emulator yet because it requires floating point instructions, which we have not implemented yet in the user space emulator. So that's another thing that we need to get back to, implementing FPU stuff. Or if anybody's interested in implementing FPU support in the emulator, then it's a very approachable project. We have so many approachable projects in Serenity, it's crazy. If anything is interesting to you, then I encourage you to look into it. So I just wanted to turn off Heap Debug so that it doesn't spam, and then maybe the global object destructor can stop spamming us as well. But man, that GC problem here was it an object? Or no, it was in shape. Yeah. Test.js. Oh, TG. Shit just works. That's very cool. So basically, the problem here was that because we were calling ensure property table, this may allocate. So it may do a GC allocation from the JavaScript heap, and an allocation can cause a garbage collection, and when that happened, then we would initiate a new garbage collection while we were already in the marking phase of an ongoing garbage collection, which caused everything to, get very surprised and go boom. So here, the reason that this is fine is because if we have a property table, then we can mark all of the keys in the property table, because the thing is, property table maps from a property name to a property value, we're in a shape. So in an object shape, the property table maps from a project name to an offset in the object property storage, and the property name can be either a string or a symbol. And in case it is a symbol, because symbols are GC allocated, we have to mark it. But if we don't actually have a property table, we don't need to mark those symbols because they don't even exist. So we don't need to bring them into existence just so we can mark them. Bringing them into existence is this is the act of lazily constructing a hash map, because the property table is really just a hash map. But because of the shape system, tracks transitions from an empty object, and every time you add a property to an empty object, we create a shape transition so that you can follow a chain of added properties from an empty object to a populated object. Then what the ensure property table would do here is that it just walks that chain of add this property, add this property, add this property, walks that chain, constructs a hash map that maps from all those names to storage offsets. But we don't need to do any of this if we don't have the hash map, because the hash map itself has no particular importance. It's just a way to do a quick lookup. If you wanted to do a slow lookup, you could walk that chain as well to find the offset. Anyway, so this fixes that problem. That's really good. And apparently we're still running here. So I ran in -g mode, which garbage collects after every thing. I think I ran in -g mode. Yeah. Garbage collects after every allocation. I guess technically it's before every allocation, but it's very often. Very busy. CPU usage 100%. It's pretty cool that we can get these pop-ups here. It's so busy that the tooltip takes a moment to render. I love this progress bar effect, by the way, in the taskbar. It's so neat. Wonder if we should show something in the toolbar for that as well. The taskbar is enough. Anyway, look at that, it completed. Very, very cool. So, commits. Dang, there's so many things going on here. Gap. Let's see what we can add from... You know what, we're gonna have to look through these. Because I did a whole bunch of little things that were just niceties anyway. So native function didn't need the interpreter argument. So let's just, can we just fix that up? Native function create. Yeah, we can just do that one separately. Okay, so those were in libjs object. Not you. Yes, you. And native function. Yes, you. And you. Okay. JS, remove unused interpreter argument to native function constructor. Yeah. Okay. Then we can do the shape fix, the one that we just did. So gap runtime shape. don't allocate or fix don't allocate property table during GC marking phase. Shape was up to no good. Triggering allocation or shape would shape was allocating property tables during inside visit children, which could cause garbage collection to happen. It's not very good to start a new garbage collection while you are in the middle of one already. Yeah. Okay, that's good. And then you know what? That actually makes me think that we should probably protect against this. So let's just quickly put something, or you know what? Let me make a note of that. To do assert in GC if GC is already ongoing, so we don't accidentally recursively GC. That will be my little to do. But I don't want to get. I'm already like many patches deep here, so let's not start stacking new changes. The strict mode change is really weird. I feel weird about that one, but I'm gonna go ahead and okay. But I guess we can just commit that and mention that we feel a bit weird about it. That's in interpreter. Yes. Okay, so JS. In strict mode work. Outside of scope. This one is a little weird. Don't know why it's okay for this function to assume that there is a current scope on the scope stack when it can be called during global object initialization, etc. We, for now, just make it say we are in strict mode when there is no currently active scope. Yeah, that one's weird. Some indentation change here, whatever. Here we are just removing some unnecessary indirections, so let's do those separately. Yes, remove some unnecessary indirection in object constructors. All right. And script execution context stuff. This one we should get rid of. Let's move the script execution context thing to bindings. I don't know why I added that to DOM. Let's see, move DOM script execution context into bindings. Web forward script execution context, come with me. You are going to go down here. Okay, DOM script X, come with me. Bindings, bindings, bindings. DOM script X. And bindings, wait. Yeah. This is much better. This one is weird. Yeah, I don't like the way that the lifetime is managed here. Something that we have to come back to. Probably this should be some way to get notified when a script execution context goes away. I don't know. We'll figure that out some other time. It's not the most important thing. Right now, at least. Maybe in the future will become the most important thing. Let me just nuke these here so that my IDE does not get confused. Document needs to say bindings here. And event target needs to not really do anything, I guess. And then I have to rerun this guy. Okay, so what more changes do we have? Now things start to become a little bit intertwined. And one thing I've been ignoring now is the test web test runner. I think probably that's broken. Yeah, it's broken, but I'm gonna fix that separately. I'm not gonna work on that now because I don't have, I'm running out of time here, so we're just gonna wrap this up and see. The script execution context stuff, I think we can add in a separate commit. So libweb. Yes. No. Yes. Yes. Yup. Yeah. That thing is not necessary there, actually. Yeah. The web. Add bindings, script execution context. This will be inherited by DOM, by documents and workers to provide a common abstraction point for script execution. Abstract, come on, abstraction. Yeah. That makes sense. Don't have workers yet, but we might as well make this little space for them now to simplify things down the road. Okay, and then this we can get rid of. can have your precious SIG-abort handler. Which is really weird, but fine. Oh, that one we should get rid of. Check out. Okay, so let's bulk this all together. Check the style. Oh, libjs plus, well, plus libweb plus libjs plus clients, let's say. Yeah. Separate heap from interpreter. Or let's see. Add Jsvm. Object separate heap from interpreter. Okay. Taking a step towards a world of multiple global objects, taking a big step. This fetch adds a new Jsvm object that represents, or that houses the JS heap. This what did we say? This means that the heap moves out of interpreter, and the same heap can now be used by multiple interpreters. And can also ad-lib them. The VM tracks, keeps a stack of interpreters. Where's and this stack is pushed, popped. We push pop this stack when entering, exiting execution. When let's say, yeah, when entering, exiting execution with a given interpreter. This allows us to make this change without disturbing too much of the existing code. Ultimately, the goal here is to make interpreter a transient object that only needs to execute, or needs to exist while you execute some code. For that, getting there will take a lot more work then. Yeah. That's pretty good. Note that in the web, the global Jsvm is called main thread. To distinguish it from future worker VMs. Yes. We should also mention that there is still a one-to-one mapping between one-to-one relationship between interpreter and the global object. That stuff has not been untangled any further by this change, and indeed may not need to be untangled. Well, we'll just say this because basically I'm thinking that if the interpreter becomes transient, it's just a thing you put on the stack while you run some code, then whatever its relationship with the global object at that point obviously changes to not be one-to-one because the interpreter is temporary. So this will change in the future. Yeah. Okay, so that's pretty good. Okay, so we're gonna have to stop here for today, but I'm pretty happy with these changes. So basically, we've added a VM object, which we can begin to move more things to. That represents sort of the execution environment in a thread. So a thread's JavaScript engine and a thread global. And we've moved the heap to the VM so that the heap can exist across multiple interpreters, which is pretty cool. And the browser works. We can do mini garbage collections. If we open this thing, everything still works. Garbage, garbage, garbage. Very cool. This is indeed a checkbox. Now run some scripts. Okay, awesome. Test.js works. Yeah, and then we also fixed that garbage collection bug and a couple of small little things here and there. So all in all, very productive session. And we're just gonna have to continue on this in the future. But for now, I gotta go. So if you made it this far, thank you for hanging out and for watching. I hope you saw something interesting, and it was nice to hack on the JavaScript engine again. It's been a while, so I guess I'll see you next time.